This is group 69 for the COGS 108 project. So our project is about stretched exponential decay of collective attention using Google Trends and Wikipedia data. So basically, we want to see, does the public's attention on an event, drop faster over time, or is it not? And we wanted to look at this because media and everything that tells us everything about our lives, apparently, that TikTok and Instagram is ruining everyone's brains, and it's basically making us zombies, and we forget everything within 5 seconds. And we wanted to see, is this true? Over time, is this happening, And background work, at least the ones that we looked at, would show that, okay, when events happen, we would expect a spike, and there's a really fast decrease. Now, we expected it to be like this exponential, which is extremely fast, but it turns out to be a little bit slower, called stretched exponential. This will be important later on, but the important thing is that it is very fast, but not as fast as a simple exponential model. And so we have our hypothesis saying, yes, we would expect that over time, the attention span to go down, and thus decay to be faster. So we have a bunch of data. We have celebrity deaths, COVID-19, Russia, Ukraine, Will Smith slap, the Tatoian implosion, all of these just to mix it up, see if we notice any trends. And so when we graph the trends data, we see that, well, there's a blip over here, over here, over here, over here, over here. A little bit different for COVID, but all of these pretty much have the same shape, which is what we'd expect. And these are really fast. So we were like, maybe it's not stretched exponential. Maybe it's a little bit faster. And let's just consider it exponential. That way we can have an easier model. So what we did was we do this thing called a log transform after we do this. So we can merge our Wikipedia and Google Trends data for each event. And we do a log transform to see, well, if it's linear or exponential, we should see kind of a line, and we don't see a line. This does not look like a line. In fact, it looks a little bit different. So what we did is okay, let's look at the background information and let's assume it's stretched exponential. Let's test it out. So we do a little bit of math. And now with this transform, we should see that it should approximately look like a line. And whoop-de-doo, it kind of does. So we are wrong about our initial assumption of exponential. We should have listened to what our forefathers told us. Those papers, they had good data. And we actually see, more interestingly, that not only does this look pretty linear, except for COVID-19 on Wikipedia, we see that the ones with the fastest decay, like this and this, Russia, are the fastest. And that's really weird because we wouldn't expect the Russian-Ukraine invasion to have the fastest decay. Basically, people forget about the fastest. We actually expected it to be more celebrity deaths because, I guess celebrities aren't that important compared to this worldly event like COVID-19 or this war. Now, we explore this further and we just say, we come out with a conclusion that's saying maybe our attention spans, we can't make a conclusion that they're decreasing over time, but we can say that the attention span on an event is just more so dependent on the event itself. So, whether it's a celebrity death or it's a worldly event, that's the more important portion. Now, we'd like to talk about some concerns we have. There is a lot of collection bias because all of these things are very Western focused. Everything is mostly English, and that's definitely a bias. Also, we were the ones that chose the events, so we have an intrinsic bias as well for what we chose, and so therefore our sample is not that great. We had a short time frame for our analysis, and also just the data is just basically people searching up for an event. So it is not that great. Now, we would like to maybe, make this more on a macro scale and start looking at, well, what kind of attention is something getting? Is good attention or whatnot? So thank you for watching, and yeah, have a good one.